the other forms are the following. In addition to 0 over 0 or infinity over infinity, we may have 0 times infinity. We have 0 infinity or plus or minus infinity, which we looked at. I mean, on these, the first two we looked at already, but additional forms are 0 to the power of 0, infinity to the power of 0, or 0 to the power of infinity, or 1 to the power of infinity. Those are forms other than 0 over 0 and infinity over infinity. The first example, I'll give you two, is the limit as x approaches 0 plus of x to the power of x. Okay? So this is 0 to the power of 0, which is 0 to the power of 0 is undefined, so supposed to equal 0 to the power of 0. So the note 0 to the power of 0 is really not, is undefined. It's not 0 as you may think. It's easy to prove that using the property of exponent, but this is a discussion for another time. You technically, you've seen that before, but let's see how we deal with it. To solve, we're going to recall the following. Recall that e to the natural log of x equals x, and we'll use this property in the following manner. We're going to say that x to the power of x will substitute x with e to the power of natural log of x. So this will be the base of a new exponential function. And then we'll use the property of exponential functions. And if you have an exponent raised to another power, you end up multiplying. So we multiply a natural log of x by x. So those are the two equivalent function. X to the power of x is equals to e to the power of x natural log of x. So instead of taking the limit of the first, we'll take the limit of the last. So this way. Okay, so and then use the property of the limit. If you have the limit of e to the power of f, then it's equals to e to the power of the limit. If you recall one of the properties of the limit, so we move the limits from here to the power. And matter of fact, this is something we worked on already. You may not remember this, but we did it in a previous exercise. So recall an earlier example where we evaluate this particular very limit. We evaluate the limit as x goes to 0 plus of x natural log of x. And we said the following. This is right now, it's 0 times infinity, right? The natural log of 0 plus is negative infinity, and of course x goes to 0. So it's undefined form of the format 0 times negative infinity, like so. But if we'll rearrange it, we'll write it as the limit as x approaches 0 plus of natural log of x. Instead of multiplying by x, we're going to divide by 1 over x. And now we are looking at infinity over infinity, or negative infinity over infinity, which qualify this limit to for L'Hopital. So we're going to say that this is by L'Hopital. We'll take the limit of the derivatives, or the ratio of the derivative of natural log of x is 1 over x. The derivative of 1 over x, being x to the negative 1, is negative x to the negative 2, or negative 1 over x squared. And as you simplify, you get negative x, or 0. That's the result of this particular exercise. So this was like a reminder tool. So now we go back and we say that the limit as x goes to 0 plus of x to the power of x equals to e to the 0, or 1. Okay. So another exercise, a little bit more involved, is the limit as x approaches 0 plus one more time of 1 plus sine 4x raised to the power of cotangent x. So as we work this out, we're going to see that we have 1 raised to the power of infinity because cotangent of 0 goes to infinity when x equals 0. Cotangent, remember, is sine over the cosine. Cosine over the sine. Cosine of 0 is 1. Sine of 0 is 0, so you have 1 over 0. So the cotangent goes to infinity. So this is a limit of the type of 1 to infinity. And we need to change something here to make it qualified, so we can qualify L'Hopital here. So we're going to use the trigonometric identities of the no, actually, we're going to do something different here. We'll have to define a new function y in the following manner. Let's define y as 1 plus sine 4x to the power of cotangent x. Okay? And now we'll apply, every time we see an exponent like this, exponential function, it's a good idea to use logarithm. So we'll apply the natural log to both sides, and we get on the left natural log of y, and on the right we'll have cotangent x times the natural log of 1 plus sine 4x, like so. Okay? And of course, we need the limit of y, and we apply the limit to both sides, and we say the limit as x approaches 0 plus of natural log of y equals the limit as x approaches 0 plus. And now, because I want a rational function, I want to have 0 over 0 or infinity over infinity, I'm going to, instead of using the cotangent, I'll use the quotient identity one more time, or the reciprocal identity. The cotangent is 1 over the tangent. So I'll have 1 plus sine 4x on top divided by the tangent of x at the bottom. And now I'm checking the limit. I have Houston, we have a problem here. Let me see. The thing is, this is natural log, so we don't have a problem. This is the natural log. I was looking to see if I have 0 over 0, because the natural log of 1 is 0, and the tangent of 0 is 0. So This is 0 over 0, so we qualified for L'Hopital. Okay? Again, this is the natural log of 1 plus sine of 0, which is natural log of 1. So now we take the derivative, and the derivative on top, we need to be real careful. It's natural log of u, so it will be 1 over u, or 1 over 1 plus sine 4x, and then the derivative of 1 plus sine 4x, which is cosine 4x, and then the derivative of 4x is 4. So we have a chain rule within a chain rule within a chain rule. And this is the numerator, and the denominator is the derivative of the tangent, which is the secant squared. And now I'm checking, and I see that the secant of 0 is 1, so the denominator has 1 in it. What about the numerator? The cosine of 0 is 1, so I have 4, and the sine of 0 is 1, so I have 1, the sine of 0 is 0, so I have 1 plus 0, like so. And so the right side is, the limit of the right side is simply 4. So we end up having the following. We end up having the limit of the natural log of y when x goes to 0 plus is 4. But recall that y is really e to the 4. So so this gives us the limit of y is e to the 4th. Okay, so and now go back to y. The definition of y, we defined it right here on top. So we end up having the limit of y, instead of limit of y, the limit as x goes to 0 plus of 1 plus sine 4x raised to the power of cotangent x is e to the 4th. And this is it. This is the answer. So this is a little bit more involved example. Think in the homework, when I gave you this type of problem, it was a tutorial type of example, so we had some help.